Okay, so before we get started, I just want to throw some terminology out there so everybody kind of understands it. So the Kafka application is made up of streams. You see the orange bars, those are each independent streams of data, meaning you can throw events into each of these streams. I've got three because in the test data set, the testosterone set that Rick gave me, I've got three different kinds of data in that bundle. There's conditions, a patient, and observations. And then I have value sets. Those aren't in that data. That's taken from the VSAC. And so I just downloaded them myself and then put them in, just save them as JSON files, and then I load them myself. So I'll load these into the Kafka application, to the Kafka server. And the important thing to note is that these are converted to Avro format, which is a binary format with a JSON schema. And effectively, the schema is registered with the schema registry, which is one of the components that Confluent brings in their Kafka distribution. And so now my producer will drop the data into the stream, but at the same time, it has to match the schema, so there's validation done, which is pretty cool. So what I do is I take the bundle and I break it up into three pieces based on what data is in it. So each different resource gets a stream, and the same thing is done with the value sets. And so I'll show you how that runs. I'm going to start up the different pieces of Kafka now and show you how that works. Okay, so to test this, we're going to go to the console and we're going to start the Confluent server, which is basically a bundling of services. So we do that, and it's going to start a few different things. First of all, Zookeeper is the piece of software that manages all the different servers. Start that. Then we start at the Kafka server. This is all running on one machine right now. So I start Kafka server with Zookeeper. There's only one instance. Finally, next I'm going to start schema registry, which is what's going to house my my data, my schema, and then lastly, there's a couple other bits that come with it that I'm not using. Connect and KSQL Server, I'm not using those quite yet. Okay, so now we're going to start the Control Center. That's the last little bit. That's a tool that Confluent has on top of it. Now everything is running, and let's go to Control Center, and we're going to see what the data looks like. So at first we've got one cluster, and then in the cluster we're going to check out the partitions. We're going to have, I'm sorry, not the partitions, the topics, and we should have nothing in there. Okay, that's just the default log. That's just a system log. And I'm going to run a producer app that I have, and it's going to load the data from that sample data set Rick gave me. Okay, now refreshing the window, we should see some new streams added. Okay, so now we've got conditions, observations, patients, and value sets in their own streams. Okay, that's good. Okay, there is one more thing I want to show you before we show the app processing, and that is these topics and what they look like. So the topics in them have some messages now. I have one partition because I partitioned by patient. I have one patient of data, so I have one partition on the server. And then the schema is something really neat. This goes to the schema registry, pulls it, and shows what the Avro schema looks like. So this is what I made. It's called condition. I made this namespace. There's clinical status, verification status. There's a codable concept for code, and so on. And all of every one of the streams has a corresponding schema. What's neat about this is you can also version these. So I can have like a version, Fire version, whatever schema. Now they correspond to Fire. Now you'll see there's a bunch of missing stuff. I only put the things that I care about. Ideally, these little JSON objects could be source controlled, and we can open source them and let others kind of help us develop them. But that's the idea. Or maybe even give it to HL7. But that's the general idea, and that's how it works. So what's neat about this is enforced. So there are, like this one I said is optional. But if I said it wasn't, for example, ID, you can see here ID is not optional. Resource type is incidentally one that I kind of made up just to kind of tell me, this one would be condition, so you can programmatically look at them. That's just kind of a housekeeping piece. But this one here, ID, it's required. You can't give me a condition without an ID, so it's enforceable based on the schema. So that's how we do it. And the nice thing about that, that's all done. So the producer would automatically get normal exceptions if they tried to drop them onto the stream, and the stream enforces that the data is good. Okay, so an important pieces of information to know about the actual application itself, now that we have data loaded into the streams, how do we consume it? So what happens, what I've done anyway, is I load this data now into Kafka tables, K tables, which are queryable, and they call those interactive queries. And I load the value sets into a global K table. The difference is that K tables are partitioned, so each server has its own local, has partitions of data, and so they just get divided to each different server. So a patient might come in and it goes to server A or server B. So I try to keep all the patients together, all their data, because I partition on patient ID. But the global table means that everybody gets a copy of it, and that's a great candidate for value sets, so that every server will get a copy of the value sets. So then what happens is now I'm able to build an application and I'm able to query these tables. So then I can take results and drop those onto a decision stream. Now in this demo app, I'll show you, I don't actually drop it into a stream. I kind of just output it to the console. But that's the idea. It's easy to drop it into a stream, but you can't see the answer unless I build another application that reads from a stream so you can see it. The other thing I want to point out is there is one issue with this, and that is because the application is querying, it is now my responsibility to make sure that this application scales. I have another design I'll show you in a minute. I haven't finished it, that's why I don't want to demo it, but I'll at least talk about the design here at the end. So let's run this demo. Okay, so what's happening here is I'm going to run this little bit of code side by side. This is the application. I'm going to run it from the console. You should see some things kind of fly by here. And then I've also got the Confluent console open up on the left so we can see the changes happening to the streams. So as we run this, you'll see that in the command line interface on the right, this is my VS Code window, you'll see that things are going to fly by. It's a lot of trace code for connecting the streams and polling and all that, but you also see a little bit of real data fly by. So let's run it. Okay, it's starting up. It's connecting and doing all this stuff. You'll see some new streams appeared on the left. Those are actually backing stores for each of the K tables. So what happens is a table is backed by an underlying stream with a single piece of data in it. So you can't have, it deduplicates effectively the stream for me. And then you'll see that it's still running and still polling, but if I scroll back up here, you'll see that there's some data here. The particular function I ran was, I think, has a diagnosis, a relevant diagnosis, and it spits out the different diagnoses. You'll see it's kind of like escaped just because I'm throwing it to the console. But these are the four tables, one for each fire resource. This is for conditions. The condition store is my table. A change log is what backs the underlying table. So effectively, when I do interactive queries under the covers, it goes to these particular streams. Okay, so that worked really, really well, but I want to show you the difference now between this design and the other one. The other one, the one I just showed you, I have to run this application and it has to query, so it's kind of polling. So I'm responsible for the lifecycle of the app and making sure it scales and whatever else. There's another method, and that is they have a DSL, which is like their own higher level abstraction language that I'm going to use. And what the DSL does is I then run some MapReduce kind of functions. I mean, I'm joining and things like that. So what I'm really doing is I'm taking the patient table, I'm taking this data, I'm turning these each into tables, and then I'm running joins on them. So I take patients, I join to problems and join to observations. Now I have a bundle of patient and all their data, and I drop it onto this stream, a new stream called the whatever bundle. It's not really a fire bundle, but that's the idea. It's just basically a list of all resources. Now the thing about that is it's short-lived. So if I update it again, I'm not worried about running out of space and things like that, because each patient will only get one of these little messages. So that works really well. What happens though is when that message is dropped onto this, it'll be sensitive to any changes that come in any stream. So a new observation comes in for the patient, it'll get rebundled and dropped onto the bundle stream. The other one will fall off. But my application now will wake up and take the bundle and do something with it. I will still interactive query with the value sets, but at least the patient data is completely self-contained. So there are no interactive queries here against the patient data. It's just constantly in the background bundled and sent. and then I compute and drop the results on there. The nice thing about that is I do not have to manage the lifecycle of this app. This app does its thing on its own, and it will automatically scale. A copy of this will go on every Kafka server in which there is a partition of data, and this will run on top, like right locally where the data is, whereas the other one did too, but I had to do all that myself. And that's pretty much it. This is what I'm working on. I haven't had it quite finished, or I'd show it to you.